All right, so today is 3.2 part 2. How's that? Is that good? 3.2 part 2. We're talking about working with the surface area of pyramids. Okay? So you know what the Great Pyramids look like, right? This is a diagram here of a pyramid. Okay, so if we just look up some images of the pyramids, so I don't know, has anyone been to Egypt here to see the pyramids firsthand? Anyone? Probably not. No, we don't have anybody in the room here that's been there. I haven't been there either. But you know about the pyramids, and you know what they look like, and so you know generally what the shape is. And so if we look at these pyramids, they kind of look like this diagram right here. There's some kind of either square or rectangular base, and then each corner of that base all come and meet at a point in the very tip, right? And so we have something that looks like this right here. That's an example of a pyramid. This is actually a square pyramid because the base is a square. All right? This is another pyramid. This is a rectangular pyramid because the base is not a square, it's a rectangle. So each of the sides are just, two opposite sides are the same, but not all the sides are equal. Okay? So those are the two types of pyramids that we're looking at. When we talk about surface area of a square-based pyramid, okay, now this one is a square-based, even though it might not look like it in the diagram, we know that it's a square-based pyramid. Why?
It's 24 by 24.
Thank you. The base is 24 meters by 24 meters. Okay? And notice that the 16 meters in the diagram is actually not the overall height. So if we're looking at this thing right here, we're not talking about the overall height here. What we're talking about is the slant height. You see, that's along the edge, the face there, the triangular face. That's what this length is right here. It's called the slant height. Okay? And that's important because if we're given the overall height from the middle of the base to the top, that's different than the length from the tip to the middle of one of the sides. That's a different length. Okay? And so you can see in this picture, I'll just try and highlight it here. This would be the overall height of the pyramid where it comes from the tip right down to the center of the base. And then this one over here is the slant height. And that's what this 16 is. Yes?
Would that slant height be the height of the triangle?
Well, if we're talking about the net, right, of the pyramid, so we have a square for the base, and then we're going to have 4 identical triangles like this. Right? This is kind of what our net looks like. And 16 is going to be, well, actually, is it going to be this length or is it going to be this length on the side? Which one is it going to be?
I feel like it's going to be the one.
Yeah, because it goes from the tip to the middle of the base, on our net diagram, from the tip to the middle of the base, and it forms a right angle. So it is the height of the triangle. Yeah. So when we're finding the area, we can find the area of the base first. That's pretty easy. Area of the base is just length times width, and that's going to be 24 times 24. So what's 24 times 24?
Gives us a solid 576.
576. Okay, I believe you. And what about the triangles? Well, the area of, let's say area 2 is comprised of all these triangles. So let's say we're going to do 4 triangles, which are 1/2 base times height, right? And so area 2 is going to be, let me bring that down here. Area 2 is 4 times 1/2. What's that base length again?
That's 24.
It's a solid 24 right there. And then the height is, so the height here is the 16 that's given. That's the height right here. Okay? So what do we have? 768. Okay, does that look right? So 40 times 16. Okay. Okay, that's pretty good.
That's 768.
768. Good. Meters squared. So if that's the case, then we add these two together and we should have area total is the sum of the two. Okay. And let's see, the solution is here on the paper. So I see a 576. That looks pretty good. I see now what is this? That's one of the triangles. Let's see if we can find the other one. Yeah, so 4 times that. So 576 times our what we said there was the 768. So does that give us 1344? I think it should, yeah. So that is the surface area of the pyramid. So remember, our net diagrams are going to come in handy, and you have to pay close attention to what you're given as far as this length here. So is this the actual height of one of the triangular faces, or is it the height of the pyramid? Because if we're given the height of the pyramid, we have to do an extra calculation, which I think will be coming up soon. Okay? So we have some chances to do this on our own. Let's, I'll tell you what, I'm going to get you guys to do number 7 on your own here. Take 2 minutes or 3 minutes, whatever it's going to take you. Do number 7 on your own, and I am going to help you with number 8 because it's just a little bit different. Okay? So you guys go ahead and do number 7 right there. Okay, so for number 7, the answer should be about 1,960 centimeters squared. So that's taking into account the base, which is 28 times 28, and I've written it this way. 28 squared, that's the same as 28 times 28. You guys might know that. But 28 times 28, 784. And then we have 4 triangles that are the same. So 4 times 1/2 base times height, which gives us 1,176. And you add those together, you should get that. Okay? So that's practice just like the example we did. I'm going to move to number 8 here. Now, number 8 is talking about this particular pyramid. This is not a square-based pyramid, is it? This is a pentagonal-based pyramid, which means that the base is a 5-sided pentagon. Okay, so a pentagon is a 5-sided figure, looks just like that I've outlined. Now, the sides of the pentagon are 18 centimeters, so that's 18 right here. And the slant height, again, we refer to this length right here as the slant height from the middle of a base to the very tip. That is 28 centimeters. What is the exposed area of the pyramid? So if this is sitting on the ground, they don't want us to calculate the bottom part. They don't need us to calculate the bottom part. So this question actually can be done, and we might do a question like this where we will have to find the area of something, a strange shape like this. But for now, we'll just talk about the area of the exposed part. Now, this is also called, and you'll see this in the next question, this is the lateral surface area. Okay? Lateral surface area. That's the side. So lateral means side. Lateral movement is side-to-side movement, so lateral means side. And then the lateral sides would be the ones that are not the base, but the ones that form the sides, okay? Lateral surface area. So, for that one, should be fairly easy. You don't have to draw a net, but I'm going to really quickly here. Okay, so if we draw a pentagon, and we have triangles that come out from each side. So it kind of looks like this. Okay, so again, you don't have to draw this, but it kind of looks like a bit of a star, doesn't it? Or a bit of a something. So we don't have to worry about this base right here. So let's just kind of cancel this out here. And we're looking at 1, 2, 3, 4, 5 different triangles, right? And so instead of doing 4 times 1/2 base times height, we need to do 5. Okay, so the area is 5 times 1/2. What's the base? 18 centimeters. What's the height of each triangle here? 28. Okay, so when you do that area, what do you get there? 45 times 28. 1,260. Can you confirm that? Yeah, somebody else got that? Okay. And then make sure we have our units. It's area, so it's units squared. Okay. Yeah, 1,260 I have in my book here. Okay? So that's number 8. Now, again, number 9 that you're going to do on your own in a little while here, because we're going to move on to the next example. But we have an octagonal-based pyramid. So how many sides does an octagon have? Yeah, 8. Octopus, right? Octagon, 8. 8 legs, 8 sides. A stop sign is an octagon, right? Has 8 sides. So that's what we're looking at. So we're going to have how many triangles then associated or attached to this base? 8, right? Okay, so we've got a slant height of 18.7. We've got the sides of each side of the octagon is 12.6. What is the, here it is, lateral surface area of the pyramid. So you're going to have 8 triangles where this is the height, this is the base. Yeah, it's going to be 8 times 1/2 times 12.6 times 18.7. Okay? Okay. So in this next example here, as we continue on, so just maybe save that question for later just to finish off. You can do that towards the end of class. So this is the second type of question you're going to get where you're not given the slant height, but you're given instead the overall height of the pyramid. So remember, if this is our pyramid right here, you're not going to be given the slant height right here, okay? You're going to be given the overall height. And that's different because, do you see this? I'm going to outline this in red up here on the screen. You're given this height right here, and we actually want this height, and we're not given it. So we need to figure out this height because the overall height means nothing to us for surface area. It will for volume. Volume is going to be important later, but not for surface area. We need this one big time, okay? But what you want to see is that we actually have a right angle triangle inside this diagram, right? You see the little 90 degree right there? And this 9 centimeters is actually the height of this right triangle, and this part that we're missing right here is the hypotenuse, okay? Now, you may say, okay, well, Mr. Maxwell, we don't have this length either. But we actually do have that length. Or we can easily figure it out. Can anyone tell us how we can figure out this side right here?
You can do 24 divided by 2 because we're finding that's a right angle, so it means it's...
Okay, very good. You can do 24 divided by 2 because this comes down right to the middle of the pyramid, which cuts this right in half. So this length is... All right, so yeah, so this is actually 24 divided by 2, which is 12. Okay? So from the diagram, you want to piece together all these little values, right? Okay, so now we have a right triangle. I have the lengths of the legs of the right triangle, and I'm trying to find what you guys told me was the hypotenuse. Do you remember what way we can find the hypotenuse given two other sides of a right triangle? Yeah, Pythagorean theorem or Pythagoras Theorem. This is what it looks like right here. This is going to be very, very handy. Okay, so we got 9, we got 12. We want to find this one. So 9 squared plus 12 squared equals the hypotenuse squared. And if we look carefully right here, 9 squared is 81, 12 squared is 144. So we get 225 is what c squared is. This is a really important step right here. To get c all by itself, do not divide by 2. If you have a 2 as an exponent right here, we need to take the square root of both sides to get c by itself. Okay? We're going to need to remember that. So on your calculator, please find the square root button. Mine is right here. And maybe you should just test this. Okay? So let's test this out. Type in the square root of 225 and see if you get 15. Make sure you can do that on your calculator. Some of you may have to put the number in first and then the root sign second. Is everyone able to do that? Wow, did that calculator just hit the ground? Let's pause for a moment of silence.
Yeah, I didn't mean to. I was trying to... Yeah, I know how to work my calculator.
Okay, all right. Don't take it out on your calculator, okay? It's not the calculator's problem. It's not the calculator's fault.
I know it's my fault, but I tried my best.
Okay, is everyone understanding their calculators?
Yeah.
You got 29?
That's what you put. I don't know how to work my calculator.
Okay, it's working? Okay. All right. So now listen, we're not done. We're not done because if we go back to the example here, right, what we found is just the slant height now. So now we have to find surface area. Okay, now we have to find surface area. So once we have that value, we see that we find the area of the bottom, right, which is, let's just go back here, 24 times 12. This is a rectangular based pyramid. 24 times, wait, no it's not. Back up to this one, 24 times 24. And then we use this c value here to find the area of the triangle. So 4 times 1/2 base times this height, which we found to be 15. So if we follow this through, this is what we should get for the answer for this example. Okay? So there's one extra step there that we have to do for these types of questions. All right. So I will start you off here. Oh wait, this one is a height of 8. So the surface area of a little base and a height. Okay, so that 8 looks like it's attached to the slant height. It's not. It's over here attached to the height. Okay, that's a little misleading, I would say. But we have to do this Pythagoras Theorem step, okay, at the beginning here. So this is 8 for a height. What is this? What is this bottom side here?
That's
12 is the whole length of this side. So if this part here is just half of whatever this side would be, right? So it's going to be 6. So Pythagoras says 8 squared plus 6 squared equals, you want to make it c or h or whatever, equals h squared. So go ahead and solve for h first, and then use that to find your surface area. Okay, so I'll just draw a net over here for you. You guys go ahead and continue on that. All right, so this should be your answer for number 10. If 8 is the overall height here, we have to find what the slant height would be. It would be 10 centimeters, which would give us a total of 384 centimeters. Okay, that's what you should get for number 10 as you finish that. Now, number 11 is very similar, except it's a different shaped object, isn't it? Number 11 is not a square-based or rectangular-based pyramid, yet it's still a pyramid, but it's a triangular pyramid. So that means that we have a triangle base and we have triangle sides. So if we have a triangle base, okay, let's say we have this triangle base, how many lateral faces are we going to have?
4.
Are we going to have 4?
No, 3.
We're actually going to have 3. Okay? So we're going to have 4 in total, but we're going to have 3. Now, are all of these the same? This is interesting now, isn't it? So what do we have here? This is really important for us to identify. 16 is going to be this right here. This is 16. Is that true?
Yes.
And all of the sides are the same length. 16, 16. That means all of these, are all these 16? Yeah, look at the lateral edges. They're all 16 as well. Okay. Okay. So do I have everything I need right now to find the area of one of these triangles? Because they're all the same. What do I need that I don't have? I have the edges of the triangle, but I do not have the, you said it, I do not have the height. So again, you need to use Pythagoras to solve for the height. So if we have one triangle looks like this, 16 here, 16 here, 16 here, I actually need to find this, so I need to make a right triangle with this being 8 and this being 8. So now I have this. 16, 8, and unknown. Does everyone see that? So this, we're going to use Pythagoras in a little bit different way now, because I don't have this side, I instead have the hypotenuse. So this is what you do. Pythagoras is a squared plus b squared, equals c squared. And I don't know what a is, okay? And let's make that the height, okay? So I have height squared, don't know what it is, I'll leave it as h, plus 8 squared equals 16 squared. You see that? So please don't just add up the squares of the two numbers you're given all the time. Don't just do that. You have to know, you have to take a look at the diagram and say, hey, I'm actually given the hypotenuse here, which I wasn't in the other question, so don't get tripped up there. So now, in order to get h by itself, we have to subtract 8 squared from both sides, don't we? So now we have this.
I did mine a different way. Probably wrong, but
Well, we'll see. Okay, so what's 16 squared? You have that?
215.
256 is correct. What's 8 squared? 64. So what is 256 minus 64?
192.
What is the square root of 192?
13.85.
Oh, 13.85. 857? So let's go 86.
Yeah.
Is it 8? Okay, 86.
856.
It's 856. So let's go 13.86. Perfect. Okay. All right, so now this is the hypotenuse. You see that? I'm sorry, this is the height of each of these triangles. 13.86. So now what I need to do to find the area here, all 4 triangles are the same. It's going to be 1/2 the base, which is actually the full 16, times the height, which is now we know is 13.86. Okay. And that should give us about, what, 444?
43.
443, you said? Okay, it depends on how many decimal places you use. So about 443 centimeters squared. Did anybody else get that?
Yeah.
All right. Okay, so that's number 11. I'll let you guys do number 12 on your own. Okay, so number 12, just set that aside. And I do want to talk to you about the surface area of cones here. Okay, so this is the second part of our lesson, the surface area of cones. And this starts on your page 159. Okay, so again, just leave number 12 for now. I'll give you some time at the end of class to work on that. Okay, so this is, here's the second part here of this lesson, working with the surface area of cones. Now, cones are a bit different. I have a cone here as well. You guys had a chance to take a look at a cone before. It's got a circular base, and because it's got a circular base, it doesn't have a certain number of sides, does it? Every point on the circular base is extended towards a single point way up here. So that's what a cone looks like. An ice cream cone, right? Ice cream cone. And that's what a cone looks like. So there's no sides. So we're not taking a look at a bunch of different triangles. In a sense, we could actually be looking at an infinite number of small triangles with width 0. But we won't go there. Instead, we'll come up with a formula that will give us the surface area of the side of a cone. Okay? Sorry, did I throw you off there?
No, I'm just saying we could go to an infinite amount. Could we?
We can't actually calculate an infinite amount. No. But we can. But we can't. But we can. But we can't.
Is that like what the other grade 11s are?
Well, that's calculus.
That's calculus. Then.
Yeah, that's what calculus is. Right? So maybe someday you'll be doing calculus, you'll be finding the sum of an infinite number of things
Yeah.
without actually counting them, because that would take a long time. Yeah, right, you can't do it. Okay, so back to this math. We have a special formula for finding out, and remember that the reason why it's a special formula and it's not a triangle is because you remember the net? Remember the net for this bad boy here? It's kind of like this. It's kind of like this. It's like a lamp. It's like a lamp.
It is like a lamp.
It is like a lamp. That's the net of a cone, remember? Okay? So how do we find, well, this is easy. Area for this is easy. That's a circle. Pi r squared. No problem. This one here now, okay? We have to include the radius of the circle, okay, that is at the bottom of the cone. We also have to include the slant height, which is the side edge here, the length of the side edge. And then we also have to include pi. Now pi, this little symbol right here, you guys should know a little bit about pi. That is a special constant that is used to calculate area, circumference, and different things, radii and stuff like that, of circles. It's a characteristic of every perfect circle. Pi is a constant that is involved in all of these calculations. It's a very special constant, and it's used in circles and with circles. So we have to use pi as well. So we're going to use the radius, we're going to use the slant height, and we're going to use pi. And so the area of this right here, the area of this strangely shaped sort of lampshade section is pi times r times s. All of the important players, pi r s. That's how you find the area of that. Okay? Pi r s. So it's kind of like a triangle with all of this, with this extra part on it, right?
I mean,
So-
can you classify that as a triangle?
No, this is not, the big thing is not a triangle because it's got a rounded bottom to it. So it's not a triangle.
Three sides.
A triangle has three sides, true. Okay, so you're saying could this be classed as a triangle?
Yeah, could we class that as?
It has three sides. Well, the sides do kind of have to be straight for the formulas to hold true. Yeah, not the perimeter. You could do perimeter with a rounded side. That's no problem. You just add the length of this side. It's going to be a little bit longer than these ones, maybe. But for the area, you can't use a 1/2 base times height. That doesn't work for this. It has to be three straight sides, okay? Good question, though. Okay, so the area, the total surface area of a cone, guys listening? The total surface area for a cone is the base, which is a circle, no problem, pi r squared, plus the wraparound part here, which is pi times r times s, the slant height. No, it's not slope. It's s for slant height. Okay? Now, again, if you're given h, the height of the overall height of the cone, you know what to do now. You use Pythagorean theorem, Pythagoras' theorem here, to find s. S is important. H we don't really care about. So if you're given h, you have to find s in order to do the surface area. Okay?
Any other possible way of doing this?
What? Is there?
Any other possible without using?
No, you have to use s. You have to use s. Okay? So make sure this is written down. Write this down. Write this down. Area of a cone, pi r squared plus pi r s. Another way to write this, which shouldn't really matter to you, but if you want, you could write like this. Pi times r plus s. That's, I mean, I don't know if that looks more confusing to you, does it? Yeah, it's the same thing. So this is also, or this one, okay? But yeah, I would just focus on memorizing this one. All right, so what does that do for us? Okay, well, they do this example here, no problem. Notice how for the wraparound part they use pi times r times s. And they use pi times r squared for the area of the circle. Oh, look at this. Ooh, there they both are. Either one. Either one. Okay, so let's do one together. One together. And then I'll let you finish. Yeah, I'll let you. I think you can finish off all the rest of the build your skills now after this one, because you know how to do the Pythagorean theorem one. See, because they just give you h here. See, they're trying to trick you in this one. They're saying, "Hey, I'm going to give you the height." Oh, what do you do now? What do you do? Well, you guys know what to do. Pythagorean theorem, right? Okay, so let's do number 13 together. Here we go. 13. Find the surface area of a cone that has a slant height of 82 centimeters and a radius of 28. Okay. I think it's really, really important for you guys to draw a picture of the cone. Better yet, draw a picture of the net of the cone. It doesn't really matter which one you do, but you need to kind of, I would sketch it out. I really, really would. So there's a circle here, and here's our net. Kind of looks like this. The little lamp there is the net for the cone. And what are we given? A slant height of 82. Oh, awesome. Right on. That's one less step we have to do, right? Because the height is around here somewhere. And I don't want the height. I want 82. The radius is half of the diameter. So if you're given diameter, you can split it in two. But they are helpful here in this nice, easy question. They give us the radius of 28. All right, look at that. 82 and 28. They like those numbers. Okay, they're just going to switch them around. So let's see. The area of a cone is going to be the area of the circle, which is what again? Shout it out. Pi r squared. What's the area of this wraparound part? Is this special weird one that we just learned? It's right. It's very similar, isn't it? Very similar to the circle. Instead of squared, it's s. Pi r s. That looks like an n. Okay, let's see if we have enough to do this. So pi times 28 squared plus pi times 28 times s, which is 82. So all we need to do is just get on our calculator, take it for a little ride here, and we'll turn that on, and we'll go, use your pi button. See, everybody should have a pi button. And then times 28 squared. And you can go ahead and do this piece by piece if you want, like do this little part first, and then write it down. It'd be a good idea. You don't have to, but do this little part first, and then take that answer plus pi times 28 times 82. And then that should give you the total here. 9676.1. 1 if we're going to go to 2 decimal places. And is this centimeters? Is it centimeters squared? Is it centimeters something else? What is it? Yeah, it's an area, so it's centimeters squared. Okay. Can you guys work with that new formula that we just learned? Think so? Okay. All right, so we'll stop there. You guys have 14, and you can take a look at this example on your own, and you can work through 15, 16, and 17. So your assignment is kind of up to 17 here for part 2, and we'll look at spheres next day. Any questions? Yep.